Hey, got a new way of doing videos now. You can see the paper that I'm working on and you can see me at the same time, okay? In a minute, I'm gonna ask you to pause this video, but not right now. Just listen to me for a minute. I want you to try all three problems on this page of notes. If you haven't printed out the notes page yet, do that, okay? Or copy these problems down or whatever. But don't turn off the video yet. First, I want you to pay attention to the instructions here. Okay, find the measure of each angle labeled with a variable. So in other words, find the measure of that angle right there where the W is. In problem number 2, find the measure of that angle there where the X is. Okay, and then in this problem, find the measure of that angle there where the Y is. Now, once again, before you stop the video, we say this. You are not going to be able to find the measures of those angles in at least 2 out of these 3 problems until you find the measure of some other angle in the picture that I didn't ask for. Okay? And this is going to happen a lot more going forward in this course, that I'm going to ask you for one thing and you're not going to be able to find it until you find something else, and I'm not going to tell you what other things you have to find. Okay? So you've got to look at the diagram and you've got to ask yourself, based on what I've learned so far in geometry, what can I find in this picture? And then when you start finding the other things, then maybe you will see a way to find the thing that I am asking you for. So again, in a moment, you're going to pause the video and you're going to look for other angle measures that you can find in these problems. And when you find them, write those measures into the picture, add them to the picture. If you don't add those angle measures into the picture, I think you will ultimately get stuck trying to answer the question that I've asked. Okay? So do that. Now it's time to pause the video and try these 3 problems. Okay, I assume you've tried the 3 problems. Here's how I might think through them myself. In this first problem here, notice I've got a straight line right there and 2 angles side by side forming, what do we call this? A linear pair. Right, I heard somebody say linear pair, which means they've got to add up to 180. So 180 minus the 129 is 51. That has to be the measure of that angle inside the triangle right there, right? That's something we learned quite a while ago. Over on this side of the diagram, here's a 66-degree angle. We've learned about, what do we call this angle over here, which would also have to be 66 degrees. Those 2 angles, what do we call those? Not horizontal pair, but a vertical pair of angles, or vertical angles. They always have to be congruent to each other. We learned that a while ago too. Okay. Now, it's also true that we could find this angle measure here by subtracting the 66 from 180, and that angle measure over there by subtracting the 66 from 180. And there's another vertical angle pair right there also. But as it turns out, those 2 angles are really not, we're not going to need those ultimately to find the value of W up there. Okay. But how do we find the value of W? Well, I'm sure some of you know and would like to tell me right now. Quiet. I don't want to hear any answers. Don't anybody shout this out. Some of you know, I know it. Some people maybe don't. Okay. Let's save it for a little bit. We'll come back and finish this problem, I promise. But let's go down to number 2. Okay. Number 2 might have been a little more difficult for you to find other angle measures besides the one that I asked for. But let me draw your attention to the fact that these lines are parallel. Okay? And here is a third line crossing those parallel lines. Now, if I extended those parallel lines through that third one, which we call the what do we call that third line? The trans what? Transversal, right? That makes 8 angles among those yellow lines. Just look at the yellow highlights now, right? There's 8 angles there. I'm going to number them. 1, 2, 3, 4. There's a 4th angle going from that yellow line all the way down to that yellow line, and then 5 and 6 and 7 and 8. There's 8 distinct angles when 2 parallel lines are crossed by a third. And in those 8 angles, all the acute looking angles are all congruent and all the obtuse looking angles are all congruent, right? This is one of the most recent lessons we've learned. And so this 72-degree angle in here must be congruent to angle number 2 and angle number 6 and angle number 7. That angle, this angle, this angle, and this angle, 2, 3, 6, and 7, they're all acute looking angles among those yellow lines. They all have to be congruent to each other. Let me erase all of that stuff and just put in what the important result is. Okay. But once again, I want to highlight it's because this line and that third line going through them, those two lines are parallel. This 72 angle here must be congruent to that angle down there. It must also be 72 degrees. Oh, and I accidentally erased marks in that angle that showed that that angle is congruent to this angle up here. So if this angle is 72 degrees down there at point J, then up here at point K, that angle must also be 72 degrees. And now I've got 2 out of the 3 angles in this triangle, but not the one that I asked you for, right? Same with this problem up here. I found 2 out of the 3 angles in the triangle, just not the one that's been asked for. Okay. And then what about number 3? Well, I don't really know any way of solving number 3 until we talk about this final fact, again, one that I know some of you know, and it's about the angles in triangles. They always add up to the same total. All 3 angles of a triangle, no matter what the triangle looks like, if you add the angle measures of all 3 angles, they always add up to the same total. What total is that? Yes, right, 180, right? Triangle angles always sum to 180 degrees. I think most of you knew that, you learned that a long time ago. Now, what's different, a little bit different about today's lesson is that probably nobody has ever showed you why that must always be true. And this is something we like to do in high school math, is talk about the whys of things. So I am going to spend a few minutes at the end of this video talking about why we know that has to always be true, not just sometimes. Not just 9 times out of 10, not just the first 1,000 times we do it, but maybe we'll get unlucky on the 1,001st time, but every time. Okay? But that's the key to finishing the rest of these problems. Right? If we know these 3 angles add up to 180 in this triangle, then all we have to do is subtract from 180 the 66 and the 51 to find the measure of the one remaining angle. So that's 180 minus 117, and that's equal to 63 degrees, which is equal to W in that picture. Okay? And in number 2, we have 2 angles whose measures are 72 degrees. So add those up, subtract from the 180, that's 180 minus 144, and so that's 36, which is equal to X. Okay. Anytime you know 2 out of 3 angles in the triangle, you got to be able to find the third. Add up those 2, subtract from 180. And now here's the last one. Now, I really have no way of finding this angle down here in this corner without finding that angle at the same time. The picture tells me that they're both the same. Okay. But again, that's not really helpful unless you know that the 3 angles add up to 180. So here's 2 ways you might do this problem. You might subtract from 180 the 128 and get 52 degrees and say to yourself, that 52 degrees is what remains to be split between these 2 angles, and it must be split evenly because the angles are marked congruent to each other. So divide the 52 in half, and you get 26 degrees for this angle Y and for that angle over there. And that solves that problem. Or here's another way that you might do this problem. My guess is most of you are going to do it this way. But here's another way you might do it. If this angle is called y, then we could call that angle y also, right? And now, if we add up the three angles, y plus 128, that has to equal 180 total. Okay. Then combine the y's together, subtract the 128 from both sides, and we will get 2y is equal to 52, and then divide both sides by 2, and you got your value, right? Subtracting 128 from 180 and then dividing by 2. That's exactly what we did in this approach here. We just didn't do it using such formal algebra, right? So that's not really much different, okay? So once again, here's the fact. Triangle angles, I'm sorry, that's kind of sloppy there. Triangle angles always sum to 180 degrees, no matter what the size or shape of the triangle, no matter how long the sides are. If one of the angles is obtuse, if there's a right angle, does not matter at all. Now, I promised you in the last couple of minutes, I'm going to show you why this always has to be true. Okay? So stick with me for these last few minutes. Here's just some random triangle. Okay? The angles could be any size. And I've just sort of oriented the triangle in such a way that one of the sides is fairly horizontal, but it doesn't have to be like that. It's just going to make it easier to look at the picture together. Okay. Now, suppose we say to ourselves, let's draw a line that is parallel to MP. Okay. But that also goes through point A. It's got to be parallel to MP. So here's a line parallel to MP, sort of. Here's another one parallel to MP. Here's one parallel to MP. But I want a line that's parallel to MP going right through this point A. This is going to help me prove that the three angles of this random triangle have to add up to 180 degrees. Okay? So I'm going to extend MP and put a couple of arrows in it. Okay. I mean, this would certainly be possible. It's not like we wouldn't be able to do this. And anytime you've got a line, you certainly can draw all kinds of lines that are parallel to it. And if we just want a parallel line that goes through the third point of the triangle, why not? Right? Well, I've actually already done this with straighter lines. Okay. Here's the original triangle AMP. And then here's a line that's been drawn to go through point A, parallel to that bottom of the triangle there. And we've got parallel lines now, and I'm going to number some angles. 1, 2, 3. Okay. These three angles, angle 1 plus angle 2 plus angle 3. Somebody ought to be able to tell me what those three angles there add up to. They are not the three angles of a triangle, right? I mean, angles 1 and 3 are outside of the triangle. And yet still, somebody ought to be able to tell me what these three angles add up to. Because look, here's angle 1, angle 2, angle 3. All together, they are forming a perfectly straight line. And so they would have to add up to what? Right, 180 degrees. Okay. We wouldn't say that these three angles are supplementary, by the way. The word supplementary is reserved for when we're talking about two angles adding up to 180 degrees. Okay. Nonetheless, these three angles still add up to 180 degrees. Now consider the fact that this line, I want to highlight this again, this line is parallel to this one. I mean, we made it that way just because we could. And now here is a third line crossing those two parallel lines. It's a transversal. And so therefore, this angle 1 right here has to be congruent to another angle in this picture that's being formed by those yellow lines. Could you name an angle in this picture? Name it. Speak it out loud to yourself. I know nobody's there, but speak it out loud. Where is the other angle? Here, the angle I'm talking about is TAM. That's angle 1. That is congruent, must be congruent because of the parallel lines to a different angle in this picture. What's the name of the angle? We're talking about angle AMP. This angle down here, right? This angle is between one of the parallel lines and the transversal, and this angle is between the other parallel line and the transversal. They're both acute looking angles. They have to be congruent to each other. So if I'm calling this angle angle 1, couldn't I call this angle 1? I mean, they're exactly the same size, right? You see where this is going? Do you see where this is going? No? Let me take my eraser. Let's erase this transversal, and let's put in a different transversal. Let's put in that one over there. That one is connecting these two yellow parallel lines. And so once again, there are two angles being formed by these three yellow lines that must be congruent to each other. And one of those angles I'm talking about is this one here, number 3, angle HAP. That has to be congruent to which other angle in this diagram that we can name. Right. APM. That angle right there. Okay. That's an acute looking angle. That is an acute looking angle. This one's being formed by one parallel line in the transversal. This one's being formed by the other parallel line and the transversal. They must be congruent to each other. So if I'm calling this angle 3, why not call that angle angle 3? Because they're exactly the same size. Now look, we've already declared that angle 1 plus angle 2 plus angle 3 is 180 degrees from this part of the diagram. But this is also an angle 1, and this is also an angle 3. And so angle 1 plus angle 2 plus angle 3 have to be equal to 180 degrees, no matter what the size or shape of the triangle. Okay? So anyway, bottom line is you got to remember that the angles of a triangle always add up to 180 degrees, because you're going to need that fact in most, if not all, of the homework problems associated with this lesson. Okay, have at it.